Hi everyone, my name is Celeste and today I'll be presenting my blended learning sequence for Year 4 Mathematics. The inquiry question guiding this unit is how can we design a zoo habitat and feeding schedule that keeps animals healthy and visitors engaged? This question situates mathematics in a real-world context. It requires students to apply their knowledge of perimeter and area and time in ways that are meaningful and authentic. The inquiry also allows for cross-curricular integration, connecting maths with science by considering animal needs and the environmental independence. The sequence of lessons for this inquiry unit aligns with 3 Year 4 mathematic content descriptors and 1 science descriptor. The first one is AC9M4M02. Recognize ways of measuring and approximating the perimeter and area of shapes and enclosed spaces, using appropriate formal and informal units. Students address this directly when they design them and measure zoo enclosures on grid paper and later refine them in GeoGebra. The second is AC9M4M03. Solve problems involving the duration of time, including situations involving AM and PM and conversions between units of time. This addressed in the feeding schedule challenge, where students calculate times for animal feedings and in the Kahoot quiz that reinforces conversions. The third content descriptor is AC9M4P01. Represent mathematical situations, including problem solving and modeling situations involving a whole number and their 4 operations. This is embedded throughout the inquiry unit as students solve authentic problems by applying mathematical modeling to zoo habitats and schedules. Finally, there is a science link as well. The content descriptor for this is AC9S4U01. Living things depend on each other and the environment to survive. This ensures students also think about the needs of the animals, their habitats, and their survival, making the mathematics more authentic and integrated. By linking mathematics and science, students see how abstract concepts like perimeter, area, and time have real-world applications in designing spaces and timetables that keep animals healthy and visitors engaged. The sequence is made up of 7 activities. The most important point is that the online and face-to-face activities are not separate. They are interconnected. You cannot do one without doing the other. For example, Padlet research is just not an add-on task. It feeds directly into the classroom sketching activity. Likewise, the paper sketches are not the final product. They're digested and refined online in GeoGebra. This back and forth between spaces reflects a blended learning design. This aligns with Jaggers and XU's 2016 findings that online course design features have a direct impact on student performance. When online tasks are clearly tied into classwork, students' engagement and outcomes improve. The design is also grounded in constructivist pedagogy. Students are not passively receiving information, they're actively building knowledge through inquiry, but most importantly, they are building it together through peer interaction. That peer-to-peer model strengthens collaboration and deepens understanding. Here is the flow of the unit in a bit more detail. We start with classroom brainstorm to activate prior knowledge. Then in Activity 2, students research zoo enclosures on Padlet asynchronously, contributing ideas that can be revisited later. In Activity 3, those Padlet ideas are brought into the classroom where students sketch and measure their own enclosure designs, applying AC9M4M02. Activity 4 shifts online again with GeoGebra, where students digitally redesign their enclosures, calculate perimeter and area with precision, and review each other's work in real time. This is a clear example of student-to-student learning, as they critique designs and offer suggestions for improvement. Next, in Activity 5, this is the feeding schedule challenge, which explicitly addresses AC9M4M03 by having students solve time problems. Activity 6 reinforces this through synchronous Kahoot quiz, where students not only test themselves, but also see their answers compared to their peers in real time. Finally, Activity 7 brings everything together in a zoo showcase. Students present their designs and schedules to classmates, answering questions and receiving feedback. This peer audience provides accountability and creates a strong student-to-student learning dynamic. Padlet was chosen for Activity 2 because it allows for asynchronous collaboration. Students research zoo enclosures, post examples with images and text, and comment on at least 2 peer posts. This builds what Glazier 2016 calls social presence, because students are able to connect with peers through meaningful interaction. Trust 2016 also highlighted the value of digital spaces for building collaborative networks. Padlet brings that into the classroom context. The key feature here is the student-to-student model. Instead of relying on teacher feedback, students engage in peer-to-peer learning by sharing resources and responding to each other's posts. This makes every student both a contributor and a learner. From a TPAC perspective, the technology is carefully chosen to support both the pedagogy of inquiry-based learning and the content focus on measurement. In terms of the SMART model, this is more than a substitution. The task is at the modification level, because Padlet transforms a traditional research task into an interactive, collaborative space that fosters deeper student-to-student engagement. The second online activity is using GeoGebra to redesign enclosures. This was a synchronous activity, with students working in breakout rooms to collaborate and provide peer feedback. The affordance of GeoGebra is precision and flexibility. Students can instantly adjust the side lengths and see updated perimeter and area calculations. This allows for trial and error learning and encourages multiple solution pathways. Here, the student-to-student model is front and center. In breakout rooms, students review each other's enclosures, pose questions, and justify their reasoning. This peer dialogue helps them confront misconceptions and strengthens understanding. This activity supports both cognitive presence as a student test, refine and justify their designs, and social presence as they build knowledge together. As Prestige and colleagues 2023 emphasize, online tools are most powerful when used for authentic inquiry. The following Chai, Ko, and Tazai 2013 work on TPAC GeoGebra. GeoGebra represents redefinition, allowing ways that simply wouldn't be possible without technology. In this sequence, the teacher takes on multiple roles: designer, facilitator, guide, and co-learner. As a designer, I would structure the flow of activities across online and face-to-face spaces. As a facilitator and guide, I scaffold how students use Padlet and GeoGebra, modeling posting, feedback, and digital design. As a co-learner, I participate in the inquiry alongside the students, modeling curiosity and problem solving. Students are positioned as active co-constructors of knowledge. Through the student-to-student model, they aren't just receiving knowledge from me, they are building it with each other. They comment, critique, revise, and explain their thinking in ways that push learning deeper. This reflects what Prestige ETAL 2023 and Trust 2016 both highlight. Digital learning environments shift the focus away from teacher-centered delivery and toward collaboration, agency, and peer-to-peer learning. To conclude, this blended sequence demonstrates how digital technologies can transform mathematical learning. Padlet and GeoGebra were not chosen as add-ons, but as tools that extend what is possible in the classroom. Padlet builds asynchronous collaboration, allowing students to share and revisit ideas. GeoGebra enables dynamic, precise modeling and real-time peer review. Together, they highlight the importance of student-to-student model in blended learning. This also reflects TPAC, where the integration of content, pedagogy, and technology produces more powerful learning. It also reflects the community of inquiry model, where cognitive, social, and teaching presence combine to support meaningful engagement. Overall, this unit highlights how blended learning can make mathematics authentic, collaborative, and transformative. It shows students that maths is not just numbers on a page, but a tool for solving real-world problems, especially when students learn with and from each other.